Hi everyone, it's Mr. Kennedy here. In this video, I'm going to introduce you to the four equations of motion. I'm going to show you where each of the four equations of motion comes from. It's important for me to state that you're not expected to be able to derive any of these equations for any SQA exams. However, it is helpful for you to understand where the equations come from. We're only going to be considering motion in one dimension and for constant accelerations. Our quantities are vectors and the directions are usually indicated by a plus or a minus sign. We're free to decide on the positive direction, but as a general rule, to the right is taken to be positive, and if it's moving vertically, up the way is taken to be positive. I'll discuss this more in the video which talks through some of the example questions. So the first equation of motion you'll already be familiar with from National 5. So we know that the acceleration of an object is the change in speed divided by the time taken. So the change in speed is shortened to v, take away u, where v is the final velocity or final speed, and u is the initial velocity or initial speed, and that's divided by t, which is the time taken. And this is shown on the velocity time graph here. So we have an initial velocity of u, a final velocity of v, and the time taken is t. So this gives us the equation A equals v minus u divided by t. And if we rearrange this equation that we're all familiar with from National 5 to make v the subject, we get v equals u plus at. And this is our first equation of motion. The second equation of motion again comes from this velocity time graph. So if we want to find the displacement from a velocity time graph, we have to work out the area underneath the graph. So this graph here has been split up into two areas. So we have area 1, this area here, which is a rectangle, and we have area 2, this area here, which is a triangle. So to work out the area of area 1, the rectangle, we use the formula base times height to find the area of any rectangle. In this situation, the base is given the symbol t, and the height is given the symbol u. So we can write area 1 as base times height, t times u. And t times u is exactly the same as u times t. So we say that area 1 is equal to u times t. Area 2 is a triangle. So the area of a triangle is a half times the base times the height. So in this situation, the base is t, so we have a half times base, which is a half times t, and then the height of this triangle is v take away u. So we have the area 2 is a half times the base, which is t, times the height, which is v minus u. Okay, I'm going to go back up to this equation here, equation 1. So v equals u plus at. If we take u over to this side, we would get v minus u equals at. So v minus u is the same as at. So back to area 2. We've said that area 2 is a half times t times v minus u. But as I've just explained, v minus u is the same as a times t from that first equation of motion. So instead of writing v minus u here, we can substitute in at. So then we have the area of triangle 2, area 2, would be a half times t times at, which then gives us a half at squared. So the area 2 is equal to a half at squared. Finally, the total displacement is then just area 1 plus area 2, So area 1 was ut, so we get ut. Area 2 is a half at squared, so we get ut plus a half at squared. And that leads us to our second equation of motion, which is s equals ut plus a half at squared. Okay, the third equation of motion, if we start off with the first equation, which is v equals u plus at, and what we're going to do this time is we're going to square both sides of that first equation. So we're going to get v squared equals u plus at squared. So the left-hand side is still v squared. And then to multiply out brackets, which you will have learned at National 5 Maths, you square the first term, so we get u squared. You square the second term, so we get a squared t squared. And then you add 2 times the product. So that gives us this term here, 2uat. So if we rearrange that equation slightly, we get v squared equals u squared, just this first bit here. And then for the last part, if we take 2a out as a common factor, we're left with ut from this term, and then a half at squared from this term here. So v squared equals u squared plus 2a ut plus a half at squared. Okay, if I now go back to equation 2, we can see that s equals ut plus a half at squared. And if we look at the term in the brackets here, it's also equal to ut plus a half at squared. So rather than writing all of that, we can just write s. So the third equation of motion is v squared equals u squared plus 2as, as shown here. So this is our third equation of motion. You can solve all of the questions that we will do in higher physics using just these 3 equations of motion. However, there is a fourth equation of motion, and that comes from the fact that the average velocity is equal to half the initial speed plus the final speed. So that's the average velocity. And we know that displacement is the velocity multiplied by the time. So if we do that, we get this formula here for average velocity, a half u plus v, and then multiplied by t for time. So we finish up with our fourth equation of motion, which is s equals a half u plus v times t. All 4 of these equations are given in the formula sheet in the exam or any end of topic test that you might do in physics, so you don't need to memorise them. And as I said at the start of the video, you also do not need to be able to show how they're derived, where they come from. So what you do need to be able to do is use these equations to solve problems. And if you have a look at the video on which gives some examples of solving problems, that will help you to lay out the questions.